In today's lesson, we're going to learn how to solve limits by rationalizing. Solve limits by rationalizing. Rationalizing. This is a long word. Hold on. We're going to learn how to solve limits by rationalizing. So why would we do rationalizing? The strategy of rationalizing a limit function over something like factoring, or for that matter, just plugging in whatever x is approaching to x. Well, I'm going to use my first example to show you why. In our first example, we have the limit as x approaches 0, that's always fun, of the square root of x squared plus 9 minus 3 divided by x squared. Now, if we were to simply just try to substitute this in, we would run into a problem. One of them is probably really obvious to you. Let's substitute in 0 and see what happens. We end up having the square root of 0 squared plus 9 minus 3 divided by 0 squared. That's already a problem because 0 squared is going to equal 0. So we for sure have a 0 on bottom. But what about on top? What do we have on top? Just to take a look and see what we get. Well, we end up getting the square root of 9 minus 3, which is equal to 3 minus 3 divided by 0, which is equal to 0 divided by 0. And that is a major dead end, and we know that we can find a limit for this problem, or we probably can. And we're going to try one strategy to see if there actually is a limit as x approaches 0 of this function. So where do we go from here? How can we manipulate this function in order to make it possible to solve without changing the actual value of this function? Well, what we're going to do is we're going to use what's known as the conjugate. The conjugate. Conjugate. Now, what is the conjugate? Well, it's a bit easier to explain with an example. Let's say we had the square root of 2 plus 7. The conjugate of this is the square root of 2 minus 7. All the conjugate is essentially this middle operation, this plus or minus. They're just flipped. They're interchanged, if you will. So the conjugate of square root of 2 minus 7 is square root of 2 plus 7, and the conjugate of square root of 2 plus 7 is the square root of 2 minus 7. Well, we're going to utilize this fact in order to simplify our problem down without actually changing the value of our function, and I'll show you how we're able to do this without changing the value of our function. What we're going to do is we're going to multiply this by the conjugate of the numerator. So why are we taking the conjugate of the numerator? Well, it's got a square root in it, and we definitely don't want to deal with that, or we want to minimize it as much as possible. So let's multiply the top by the conjugate. Our conjugate is x squared plus 9, the square root of x squared plus 9, and all we have to do is change this to a plus sign, plus 3. Now, here's the problem. If we were to just do this, we would be fundamentally changing what this function is equal to. So what we need to do is multiply by 1, which means this bottom needs to be the same thing. To explain this further, x squared, the square root of x squared plus 9 divided by the square root of x squared plus 9 is equal to 1. It's the same thing divided by itself. And 3 divided by 3 is also equal to 1. So technically, we are just multiplying by 1. We are not changing the value of this function at all. The conjugate is a sneaky little trick we can use to change the value of this without ruining this function's original value. We don't want to change that at all. We just want to multiply by 1 and make it look different. Now what we got to do is multiply this by this, and that's going to require FOILing it out. So let's do that over here. We have the function, the square root of x squared plus 9 minus 3, and we are multiplying that by the square root of x squared plus 9 plus 3. So what we're going to do is we're going to multiply each one of these by each value, and we're going to FOIL it out. So the square root of x squared plus 9 times the square root of x squared plus 9 is just equal to x squared plus 9. A square rooted value multiplied by itself is just whatever value is inside the square root. That's a nice little trick to know as well. Next, we're going to do the square root of x squared plus 9 times 3, which is just equal to 3 times the square root of x squared plus 9. And now we're going to FOIL for negative 3. Negative 3 times the square root of x squared plus 9 is equal to negative 3 times the square root of x squared plus 9. And negative 3 times 3 is just equal to 9. Oh, that should be a plus sign there, my bad. You may notice that these two values cancel out, so boom, we don't got to worry about that no more. Oh, another mistake over here. This is supposed to be a minus 9. This is a minus 9 because negative 3 times positive 3 is negative 9. That makes a little bit more sense because now our 9 and our negative 9 cancel out. Cross that out. So our numerator is just equal to x squared after all this factoring stuff. And that sure is a whole lot nicer than this mess over here. Now let's do the denominator. And in fact, the denominator is going to be pretty simple. So we have x squared times the square root of x squared plus 9 plus 3. And I'm not going to change that at all. This is just going to be our denominator, and that'll make more sense in just a second. So let's put our numerator and denominator together and back into our limit problem. I'm going to grab my other pen. So now we have the limit as x approaches 0 of x squared on top divided by x squared times the square root of x squared plus 9 plus 3. And you may notice that we have an x squared on top and an x squared on bottom, and those two will cancel. So now our new function is simply the limit as x approaches 0 of 1 divided by the square root of x squared plus 9 plus 3. And this will not turn into 0 divided by 0, and if we were to plug in 0 here, we would get the square root of 9 plus 3, which will also not equal 0. So now that we have a much simpler function that will not equal 0 divided by 0, let's plug in 0 to our function. So this is now equal to 1, that doesn't change at all, divided by the square root of 0 squared plus 9, all, and then add 3 to that. So let's simplify this down. This is equal to 1 divided by the square root of 9 plus 3, which is equal to 1 over 3 plus 3. And our final answer for the limit as x approaches 0 of x squared plus 9 minus 3 divided by x squared is equal to 1 over 6. And that is the limit. And we are able to find this limit because of rationalizing. Now, I know it looks like a really long process, and I won't even lie, this step is kind of a pain, but it goes by really fast with a lot of practice. And in fact, we're going to do one more example for this video just so you get the idea down. Erasing, erasing. Our second and final example for this video is the limit as x approaches, and let me check my notes, as x approaches 2 of square root of x plus 2 minus 2 divided by x minus 2. Now the obvious red flag here is if we plug in 2 for our x values, we get 2 minus 2, which is equal to 0. Still can't divide by 0. That hasn't really changed in the last 10 minutes. We also end up getting 2 plus 2 under the square root. The square root of 4, which is 2 plus 2, is equal to 2. 2 minus 2 equals 0 divided by 0. We're in the same predicament as last time. But we can also solve this with the same strategy we used last time. Let's use the conjugate of this numerator and make this problem rational. So we can once again multiply by 1. In other words, multiply by the conjugate on top and bottom. So that is equal to square root of x plus 2 plus 2 divided by the square root of x, x plus 2 plus 2. And once again, we're going to have to FOIL and do that whole process, but I'll walk you through it. Let's do that over here. First, we're going to do the numerator, which is equal to the square root of x plus 2 minus 2 times its conjugate, which is the square root of x plus 2 plus 2. Foiling this out, we have the square root of x plus 2 times the square root of x plus 2. The square root of two values that are the same multiplied by each other is just whatever value is within the square root. So this is just x plus 2. Now we have the square root of x plus 2 times 2. So then we just have 2 times the square root of x plus 2. Next we have minus 2 times the square root of x plus 2. And lastly, we have negative 2 times 2, which is equal to negative 4. Once again, these two will cancel out. So then our value just turns into x plus 2 minus 4, which is equal to x minus 2. And this will be our numerator. Let's do the denominator now. Our denominator is simply, let me get my red pen out, x minus 2 times square root of x plus 2 plus 2. And once again, I'm not going to simplify this because you may already notice that some values are going to cancel out. So let's rewrite our limit problem from earlier with our new numerator and denominator. All of this is equal to the limit as x approaches 2 of our numerator, x minus 2, divided by x minus 2 times the square root of x plus 2 plus 2. Just like last time, we have a numerator and denominator value that cancel each other out. Bada bing, bada boom, just like that. So now our new equation is the limit as x approaches 2 of 1 divided by the square root of x plus 2 plus 2. And just like last time, if we were to plug in 2 for x within here, we would get 2 plus 2, which is equal to 4. The square root of 4 is just 2. 2 plus 2 is not equal to 0, so we won't divide by 0, and our top function is just 1, so obviously that won't be 0 either. And in fact, let's plug in x approaching 2 for all of our x values in order to solve this limit problem. This is simply equal to 1 divided by the square root of 2 plus 2 plus 2, which is equal to 1 divided by the square root of 4 plus 2. And I'm kind of running out of room down here, so forgive me for this, but we're going to move over here. So this is now equal to 1 divided by 2 plus 2. So the limit as x approaches 2 of the square root of x plus 2 minus 2 divided by x minus 2 is simply equal to 1 divided by 4. And that is the answer to our limit problem. I hope this video was helpful. I know this is a bit of a long strategy, but it's very useful in certain scenarios. If you need more Calculus 1 lessons, I am your guy. Consider subscribing to the channel and watch the next lesson where I go over some other ways we can solve limits. I'll see you guys in the next video.